I'll be the one that saves me. You've always been the one, yeah, that'll never change. Bright like the sun, but real like the rain.
Birds flying, boy jumping, or planets revolving around the sun. What do you see common in them? Yes, they are all in motion.
So, motion is defined as change in position of an object with respect to time.
There are many types of motion, but in this chapter we will typically deal with motion in a straight line, which is also known as rectilinear motion. But first, we should develop our concept about reference point and frame of reference. Let's imagine I'm walking from my home towards my frame in a straight line. And now, if you ask me, what is my position? And if I tell you my position is at 50 meters, you will be confused, isn't it? You will say 50 meters from where? From your home or your frame? And then, if I tell you 50 meters from my home, yes, now you exactly know where my position is. So, I am referring my house to define my position. This reference object in our coordinate system is known as reference point, which is the origin. This coordinate system, along with the clock, is known as frame of reference. Now, let us see about distance and path length. Distance is the total path length covered by an object, regardless its direction. So now, let's take an example. This ball moving from O to B, which is 50 meters away, and again coming back to O. So here, the total distance equal to 50 plus 50, that is 100 meters. Okay, now let's talk about displacement. So, displacement is the change in position of an object, that is, the shortest path between the final and the initial point. Now, look at this. This car moving from home to office, which is 200 meters away, and from office it is moving to the store, which is 150 meters away, and again it's coming back from store to office. So the total displacement here is only the path between the home and the office, which is 200 meters. But the distance is from house to office 200 meters plus from office to store 150 meters plus from store to office another 150 meters. So total is 500 meters. But we said the displacement has direction also. So how do we determine the direction? We can observe that motion in one dimension can only have two directions, positive directions and negative direction. Now look at this example. When the ball moves from O to B towards positive direction, the displacement is plus 50 meters. But when the ball moves from B to A, the displacement is minus 100 meters. The positive and negative sign shows the direction. From the observation, we can conclude that the magnitude of the displacement may be equal or less than the distance covered, but can never be greater than the distance. Now, what is average speed? Average speed is the total distance covered divided by total time interval during which the motion has taken place. Now, let's look at this example. The car moves from home to office 200 meters in 5 seconds. From office to store 150 meters in 20 seconds. And again from store to office in 10 seconds. So the average speed is total distance by total time, that is 500 by 35 meter per second. That's equal to 14.28 meter per second. Average velocity. Average velocity is defined as change in position or displacement divided by total time interval. Now let us see how to find average velocity between 2 points on the graph. The average velocity will be the slope of the line joining those 2 points. Now let us look at an example by giving some value on the graph. Average velocity, that is V bar, is equal to the slope of this yellow line, that's equal to x2 minus x1, which is change in displacement, divided by t2 minus t1, which is change in time, that's equal to 40 by 3 meter per second, that's equal to 13.33 meter per second. Okay, now let's see about instantaneous velocity. Instantaneous velocity is the limit of the average velocity when time approaches to 0. Okay, now let's start from an easy one. What will be the instantaneous velocity during zero acceleration or uniform velocity? At any point of the graph during zero acceleration, the instantaneous velocity will be the slope of the graph itself, which is constant. We can clearly see that the slope is constant throughout the time. So, the instantaneous velocity will be the same at any point on this graph. Here, let's find out the instantaneous velocity at point B. So, let's take the y value of B, then divided it by the x value. So here the instantaneous velocity equal to 20 by 2 meter per second, it's equal to 10 meter per second. But how to find instantaneous velocity during acceleration? If we mark 2 points and try to find velocity between it, you will say, isn't it the average velocity? Yes, but we will reduce the time very small, that it almost instantaneous. That is, delta t approaches to 0. So now, what is instantaneous speed? The magnitude of instantaneous speed is same as instantaneous velocity, but only without the direction. The next part we will dig deep into acceleration and try to understand calculus. Till then, keep loving nature.
Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up.